Right, that's good. Let's minimize this. Okay, now we're going to talk about the ADHD in neuroscience. Basically, when we are talking about ADHD, we can divide the brain into two sections. So the performance brain, doing brain, and knowing brain. So basically, the kids with ADHD, he knows what to do and he knows the correct behavior. But when it comes to do it, he cannot perform it in a good way. So the executive function, the way he is organizing his behavior, it's extremely disconnected from his knowing brain. And that's what we can see it in our analysis when we do the brain mapping. This is what we call it EEG. This is the brain recording and mapping. And this is when we analyze it. We can see on the middle of the brain, we call this vertex, over the C3, C4 area, it's have like an eyes in his brain. And that's what we call it disconnected between the prefrontal cortex and the rest of the brain. And that's what causing lots of problem in his executive functions. Now, the way we measure the impulsivity by giving a test, we call it Stroop effect. And we know it's very common and very famous test to measure the impulsivity, how much the person will be able to inhibit or he can perform. So you can find this application on an App Store. I would like to jump directly to the brain waves because I want to go directly to the neurofeedback. So when we are talking about brain waves, basically there are different brain waves bands. So we have a delta when we are in a sleep, and we are moving from slow brain waves to the faster brain waves. So at the left of the screen, we can see that the delta, it's 1 to 4 hertz, and we can see it when we are asleep. People who got concussion or brain injured, the delta will be dominant brain waves in this case. Next brain waves is the theta. And when we are tired or we having students in our classes with lots of daydreaming, so he is there physically, but mentally he is not there. So basically the theta, it's going to be the dominant brain waves when we do our brain mapping for this particular boy or girl. The next one, brain waves, is the alpha, and when we are relaxed and just paying attention in a relaxed mood, focus but alert. So we are not sleeping and daydreaming, and also we are not in a hyper thinking and arousal level. The next brain waves, we call it low beta, and it's when we are on 12 to 15. And we can see here SMR, sensorimotor rhythm. This is very important brain waves when we are in our sleeping onset phase. When we go to sleep, we want the SMR to be to be activated in our brain. So our brain will isolate the stimulation from the environment to enter to the brain. And that's what will enable us to go for a deeper level of sleep. And now this, we would like to have this, and we stimulate this brain waves when we want the person to relax his body. So we uptrain this area so that the body will be more relaxed and eyes open. Now the next brain waves, when we are focused, we call it beta, and we have high beta when we are stressed. So we have two levels or three levels of beta. We have low, and we have normal, and we have high beta. The best way we can discriminate between them, it's by the level of stress. So if you have someone who is doing an exam or a test, so if you ask him to write maybe in any topic, something he likes it, he's gonna produce this in a low beta level. So he enjoy it, and he likes the topic. And if you give him a little pressure of time, you tell him, okay, I'm gonna give you a topic, something you are not familiar with, but with half an hour to write it. Now, if you want like to stimulate the high beta, you could put him in maybe a different language. He is not qualified and he is not strong enough in this language, and you put pressure on time on him, and that will generate lots of high beta. So he is in a stress level of problem solving level. So you can try it with your kids. Give him like pressure on time, pressure on discomfort and the cognitive ability, then find out who is performing in a correct way, but in a different pressure. Now, the last brain waves we talk about, it's a gamma when we are in a magical or in inspiring, or we call it aha moment. This is when the brain work in synchrony across all areas. Now, this is the levels of our conscious level. So we're talking about gamma, the highest level, and we can see it in our, so this is the physiology, and this is the psychology of our awareness. So in the gamma, it's the highest level, so we hyper alert or in a manic level, and when we are in delta, we are sleeping. But still, inside the delta, we can talk the deeper level of conscious, unconscious level, which is the coma, and we have 4 levels of stages of sleep. Then we have drowsiness and awake and alert and so on. So brain waves, it's an indication about our conscious level. We can move also when we talk about alpha, which is the middle, they call it the king of the brain waves. There are norms to classify the normal from abnormal alpha level. So this is the most important one. And some researchers, they consider this, if he is in 8, his brain waves also, it will be 8. So to remember this, the middle age, it's in 8, and the more he is growing up, the elderly, and he is in the younger level, it will go down. So also some elderly in the alpha level, their alpha, it's sometimes it should drop down up to 8 or 7 if he has dementia or brain damage. This is another way of studying the brain by divided into location. So we have the left brain and we have right brain, and these are the electrode placement, and this will help us locate the exact location of the problems when we analyze it. This networks, I would like to go for, these are when we are in aha moment, it means our gamma, and when we find a solution for any puzzle or any challenging work, basically we are in a gamma. And we can see here your students on the classroom, this is in a delta phase, daydreaming theta, and this also on theta. And we can see students who is in a beta level when they are working very hard on solving their problems. Here we can see the theta in this eyes where the student is in a daydreaming, And here we can see the focus and beta generated with a written form. Here we can see it's high beta, it's under pressure, some high level of arousal, and this level of squeezing the mind where we are generating the high beta level. Now, this is from the sport level. I don't want to spend too much time here, but we can see here also the theta where the students, he is there, but he is having his daydreaming. And here we can see the high level of pressure and the high beta it's generated. And in sport, sometimes we use VR to treat the ADHD kids, and it's very common solution now. I would like to show the neurofeedback technology. This is very important concept in analyzing or understanding the importance of the limbic system where our emotional brain, and we call this amygdala hijacking concept. You can Google it and study about it. So if we have the amygdala, where it's the fear center of the brain aroused, basically the brain waves from the thalamus, it will not be able, this is the thalamus, it will not reach the surface and come back. So the remote control, if the person or the student is in a fear state or he is scared, the amygdala will be holding all the information, and he will not be able to process the information in his prefrontal cortex and thinking clearly. So we'd like to first make sure we are creating a safe environment, then the brain will be able to process and do the thinking on the surface. These are maybe a recommendation, and I will send you this presentation. These are standard. If you are going to use the gaming in your learning, make sure that you got these standards in your gaming if you are going to use it in your learning. So this is another representation of high level of emotional and it's same as amygdala hijacking. What we are looking for basically to bring the learner to be in a optimal arousal level in the zone, not hyper or hypo level or boredom. These are the networks, but I would like to jump to this. This is what we mean by neurofeedback. So what we're doing in the neurofeedback, this is the learning process in the neurofeedback. So it's a learning process. It's not like we are thinking bringing like electrical shock to the brain. We can see we put the electrocab on the students or the learner, and we pick the brain waves. Then we process it here in the software with the hardware, and we analyze it. Then we find out if we have here a student with high theta. Basically, he will be lots on daydreaming. Then we put a threshold for him. So if he bring down his theta, he will be able to watch the video, and the video will be moving, and he will hear the sound. This is the feedback loop. So basically, as you can see, the arrows, it's going away from the brain, and what we are bringing back is the feedback through auditory and visual input. It's like a mirror for the brain. We show the brain the way it can adjust itself. So exactly the feedback, when I stand in front of the mirror, I try to adjust maybe the way I look, and it's basically the same thing. And here we can see it in a regular clinical setting. This is the screen with a clinician, and we can see here the amplifier. We are using amplifier because the brain waves, they are very, very tiny and very, we cannot like measure it, unless we amplify it. And we're talking about microvolt. It's 1 million of the volt in the brain. Now we connect this and we connect it with a TV. And now the learner, he is getting a feedback from the TV itself. Now we can see here that the clinician could also use the screen of the computer as a feedback with some ADHD students. So the process of we measure by doing a brain mapping, then we do learning, then we optimize the brain function. That's exactly what we do. So the brain mapping, we use the electrocab, and it has 19 electrode placement. We connect this to the amplifier, then we measure the brain, and we can see here we call this QEG, and quantitative electroencephalograph. The Z score, it's on the green. So everything in the green, we can see it in the brain. It means in a normal range. And if we see the red color, it means it is 4 standard deviation from the norms. So basically we can see some abnormalities and some normal brain waves. The target groups of neurofeedback, in my practices, I've been in this since 2009, and I'm using this with at the therapeutic level, and lots of executives, people who is working on a leadership role, who's been working for the last maybe 10, 15 years under pressure. Definitely they're gonna lose some of their brain function. You can, like, either memory, sometimes they are losing their attention, sometimes they're having problem in emotional and controlling their temper. And also I use it a lot with athletes. Next week I have a presentation with the sports psychology conference in Saudi Arabia, and I will talk the application with use it with lots of sport athletes. And I used to work on Aspire Academy. It's academy for elite students in sport, and I use this technology with them a lot, and it's bringing, and I'll show you some example. And I'm using it a lot with the students with the learning disabilities, attention, and the major biomarker in their brain. It's the we can see it on the left hemisphere behind the left ear, where the language centers, Wernicke's area. It's extremely deficit. And also there is lots of research, especially there is a research on from British research, and in England they are using this technology for enhancing the performance with dancing academy, and they are getting a good result in this direction. So is this a new field? Basically it's beyond 1950. Joe Kemia, he started teaching people how to control their alpha. And we have also Barry Stearman. He used this technology to control seizure in some cases, and to stop seizure as well, epileptiform seizure. And also use it with hyperactive sample. And also we have a very important research done by researcher Benston. He used it with addiction, and the sample was around 100, and the effectiveness was around 85%, could stop their addiction without relapse. We know the major problem in addiction is the relapse. And the progress in this direction in a neurofeedback, it's booming. I remember in 2019, I managed to to make a presentation for the Aspetar Hospital. And the PubMed website, it's very famous on the medical research. There was around 900 research in neurofeedback. Today I was doing the same in neurofeedback, researching and find out how many research now. The number is more than 4,000. It's booming field. And maybe I can share this. This is the 700, I mean. And this one, maybe 2 years ago. But today also I double check this, but it's the number, it's doubled. It's double times 2 now. Let me go for some cases, because I can leave this with you. And this is one of the famous history, and use this with athletes. This is the Italian team in 2006, and they won the World Cup final. But the story started with them in 2005. There were 5 players in AC Milan club, and there was a sports psychologist. His name, it's Bruno De Michelis, and he's during the Champions League final, whereas AC Milan and Liverpool, they have a game at the final for European Champions League. And the first half of the game, AC Milan, they were scoring 3 goals. Then second half, Liverpool, they score 3 goals, and AC Milan, they lost the game when they go to penalty kicks. So the management of AC Milan, they go for this psychologist, and they told him, how come we hire you and we lost for psychological reason now? How can you explain this? Then he told the management that if you want more result, you need to invest in a different direction. Then he told them about the bio and neurofeedback. Then they put like labs for him in AC Milan club. Then he started teaching and training the player about this technology. In 2006, there were 5 players from AC Milan who been trained on this technology, and they were the core of the Italian atrophy in this competition. Sometimes I work with national team players. This is a national team player who's been referred to me as a football player, and we can see here the subcortical level, the as Loretta. The standard deviation in the delta, it's 8.5 standard. This is not a number. This is very high level of hyperactivation, and the memory, it will be affected badly in this level, and theta as well, 6.2. Now, this player, he was struggling in paying attention in the field, and a national team coach, he said he doesn't want him in his team. So he was about to kick him out. Now, when we did brain mapping for him, now we can see over the C3 area and C4 area, there is some sleeping spindles within the first 36 seconds of the recording. So the normal people, they could start having drowsiness and losing their vigilance and attention after 360 seconds. It means after 6 minutes or 5 minutes, it's normal to lose your attention if we ask you to focus on object in front of you. But for this particular guy, he was losing his attention, and when I was watching him, he's like taking a quick nap, then he get back. Like he couldn't sustain his attention for a long time. Now, he spent more than 4 months trying, the psychologists, the different clinicians, they tried to diagnose the problem. But when we discover this problem, and we know that it's a sleeping problem, we could fix it within 3 days. So he put himself in a sleeping hygiene program, Then he was one of these people holding the Asian Cup with this team. Now, we can talk about lots of different cases who's been benefit from this technology. This boy, he was on the Aspire Academy, and he's a good player, but national team players, 15 years old, then he was, most of the time, he is receiving yellow card. We have yellow card and red card. So yellow card, if you collect 4 yellow card, fifth game, you will not be able to play. So in his season, first season, he was doing like 16 yellow card. Then I show him his brain map, and I show him the way it is. It's hyperactivation with 6.8 standard deviation. It's way above normal. And his limbic brain, it's the first wired response for any stimulation. So that's why he is receiving these big yellow card. Now, next season, I managed to see him, and the end of the season, I told him, okay, next season, how many cards you get? Then he said, this season I got 4 cards. Now, we just did visual feedback for his brain function. This case, dyslexia case, couldn't make basic mental math. So if you told him you have $5, you went to the grocery, you spend $3, how much there left? He could tell you 3. So 4. The way he answered, it's like lacking for confidence, and very important progress. After 30 sessions, we can see the difference at the subcortical level, how much 4.6, it's dropping to minus 0.9, and maybe in his high beta 6, it's 2.8, and we are talking about normal range and a beta, also the reduction and shrink in the red color. This case also we have, this is my son, and I train him for reducing his anxiety at the high beta level, and we can see, we find him end of the season scoring 35 goals after 20 sessions, and the major observation in his sport performance, that's the rebound. So when he is losing the ball, he was able to collect it again in a quick way, and his stamina. So when we started training, he was doing like 25 sit-up. Then he told me, Dad, I can do more than 25. I told him, okay, do whatever you can do. Then he reached 100. This is his stamina. It's improving significantly. And if we can move forward. Okay, this is very important slide. And you can see this word. This is addiction brain. And we can get from artificial intelligence analysis. Basically, what we do, we do the brain mapping, then we upload it in a website with normative data. Then we measure this particular brain with the normative data, and this gives you a possible deficit. And you could like get kids as small as like 4 or 5 years with this biomarker addiction. This is very scary. Now we have this boy also. This boy, he is I worked with him in Aspire Academy, and we can see before, this is before, and this is after. The way you compare it, you go for delta here, then you compare delta here. So this is his theta before, and you compare it here. And this is his alpha. You can see how hyperactivation in alpha, it makes lots of anxiety. This particular boy, for anyone just talk to him, he could start crying. Now, after reducing his alpha to this level, we start seeing like he failed 4 subjects in the first term. then 0 failure subjects in the second term. This is significant difference. But I was training him for academic achievement, but we find out some significant performance progress in his football. So in the first half of the season before COVID-19, he scored 20 goals. Now we start over again, but he never scored this goals anymore. So these are, we find out when we train the brain and we optimize the function of the brain, and for academic reason, also we get like in a sport or in the life as well. Well, this is him again. And we have this little lady. She is in high school, and her mother, she brought her. And the first term she scored in the government exams, 61, and she's failing 4 subjects. And she was addicted to coffee. We got biomarker of addiction in her analysis. She drinks from Starbucks 7 cups, large cups a day. So she's trying to keep her brain awake so she can study. Now, I trained her maybe around 15 sessions before COVID. Then after maybe 6 months, her mother, she called me. The result of the second term was she's scoring 75 and she failed 1 subject. And there is a system in Qatar, they can do like a makeup exam. And I trained her before the second session exam and she passed. Now she's studying in Qatar University. And this is images for her, before and after. This is, you can see before and you can see after. Also, these are images for her. And now this is a review session from her training. So we hook up the electrocab on the brain and we have her look on the video or whatever, or sometimes reading. Now, these are the early stages of training. We can see her theta, how disturbed. And the theta here, it's 26. Then after maybe 15 sessions, we can see a theta, it's bouncing in a normal range. It's 13 microvolt, which is a significant reduction. And this is mid-frontal theta. So if we have a theta in the brain in the middle and frontal, a very high theta, it will generate ADD syndrome biomarker. People or students, they will not be able to focus for a long time. And we can see the theta itself. This is another way of training the brain. We take a look here at theta and we can see it's stronger and longer. If the theta go up, it means she is losing the focus. And if it's go down, it means she is focused. But this is a very good attention span. And the way we do this training, sometimes I give her like a paragraph to read. And if she is reading and she is understand and doing comprehension for whatever she's reading, we can see that it's going down. But if she is losing her attention for at least like 1 minute, that means she is not understanding. So I bring her back, then we start over. So if she go down and she start reading with going down in her theta, that means she is paying and she is understanding. And the way you can check this by asking the question after the silent reading. Now, I asked this particular girl, what is the difference in your learning before and after? This is in Arabic, I can translate it. She said, first, when I was opening my book I couldn't like focus more than 5 minutes, then I feeling sleepy and drowsy, and I cannot understand, I cannot focus for a long time. And also when I read, I cannot understand whatever I'm reading. and with inside the classroom, most of the time I was having daydreaming. And now after the training, she said, I was reading for like 1 or 2 hours without losing my attention. Then I do understand what I'm reading, as well as I start asking a question in the classroom. So she is more engaged in her learning. I would like to come to the end of this presentation at this level, and I will love to hear any questions from any one of you. It was a very quick one, and I hope it helped you at this stage to get the idea.
Dr. Badli, this has been very, very interesting. I'm sad to say that we have 2 minutes and 45 seconds left before we get cut off again. But I do know that there was a question in the chat box. And it said, does ADHD have anything to do with high sensitivity hearing?
What's the question again?
Does ADHD have anything to do with high sensitivity hearing?
Yeah, this is it. It's I think the sensor integration area, it could trigger the ADHD syndrome. And we have a very important question. Is the case, is he really ADHD, or there is another reason for trigger this kind of behavior? So sometimes we find out the sugar intake, how much he is taking glucose, and he's not paying attention to his food. And sometimes sleeping could trigger symptom as ADHD, and hearing sensitivity. If we have kids, and I'm working with some kids who having this problem, and they've been diagnosed as autistic because of their hypersensitive to the sound. And the way we deal with this, we are make sure first he does not have an organic problem. He has hearing is intact. Then we know it's a functional level. Then we try to find out if we could help him to do sensory integration training with a neurofeedback. So the question for this, the answer for this question, yes, there is a strong correlation between the hearing sensitivity and ADHD.
So now we have less than 1 minute. And so I'm going to formally say thank you very much for your time today. I know I learned a lot, and I'm sure everyone else did. Please take a picture of his contact information on the WhatsApp so that you can send questions directly to him. And we look forward to our next meeting with him, which is in a couple of weeks, I think. So I will be sending out more information about that. And we look forward to seeing you again, Dr. Badli.
All right. Thank you.
Thank you, everyone.
Bye.
Thank you so much.
In the meantime, I'm going to upgrade my